Good morning, everyone, or good afternoon, or good evening, or good night, wherever you are watching this, whenever you are watching this. This is Execution Plans. Where do I start? A great session to kick off the last day of Past Virtual Summit 2020. I'm glad you all are here. For the record, those who are interested in the Past to Prizes game, I have been informed that there might be a QR code shown near the end of this session, so hang on and make sure you have that scanner ready. Apart from winning prizes, PASS has much more to offer, so explore all the great things they do. We are now at the PASS Summit, which is the event they use to raise money. On the screen, you see all the things they do to spend that money and give back to the community. So please make use of all the opportunities they have available for you. What I would like to ask of you in return for the time I'm now spending teaching you is to help me get better at what I do, presenting. So if I did a great job, fill out the evaluation, give me a nice thumbs up, makes me feel good. But much more important, if you think I should have done a better job, let me know. Go to that evaluation. Rate me as low as you think I deserve and tell me why. Because if you tell me why, and there is you have the option to give the additional information. If you tell me why, then I can actually do something with that feedback, and that's how I get better. The same feedback is, of course, also important for PAS, who is this year experimenting with a virtual format. Hopefully, not needed again next year, but it's always good to have the feedback and to know what went wrong and what went well. So please take a minute of your time, and that also might land you a prize. My name is Hugo Kornelis, and I make SQL Server Fast.com. SQL Server Fast.com is a website that I started creating a few years ago because I realized execution plans are awesome tools for performance tuning, but the amount of documentation available created by Microsoft and the quality was sorely lacking. And there was a lot of stuff scattered across the web, and I realized I would like to have a central repository where all the documentation is available and where you can just go and find everything. Now, I could, of course, start bugging Microsoft to make it, but I know that it's very hard to change the course of an oil steamer. So I just set up this website and started doing this myself. Now, if you are the intended audience of this session and not just jumping by because you are interested in what I want to talk about, if you're really starting with execution plans, then the execution plan reference is not for you because it's a reference. It's not a teaching website. It's a website where you look up stuff. So it's very detailed, it's very in-depth, and it doesn't have much explanations. However, I've also started doing the SQL Server execution plan video training, where I am slowly but gradually producing hours and hours and hours of video content where I teach the audience everything I know about execution plans. On SQLServer Fast.com, I also have a lot of other content. For instance, the resources to all my presentation decks and demo code. So if you want to review this presentation later, go to my website, download the slide deck, download the demo code, and while you're at it, do the same for all my other sessions and learn a lot. I do a lot of other stuff as well, but I'm not here to talk about myself. So the only thing you really need to remember about me is you can mail me if you have questions, or you can tweet me if you have questions. If there are community questions related to the stuff I present about, I'm always happy to try to help people find an answer to that question. And again, go to SQLServerFast.com, click other presentations, presentation resources, find the session and download the slide deck and the demo code so that you can review it later or play with the demo code. So we have a lot to talk about and not much time, so let's dive straight in. Today, I'm going to talk about how to start working with execution plans. But before I even do that, I'm trying to convince you, why should you care? Of course, the fact that you are watching right now suggests that you already have a hunch that execution plans are relevant. But perhaps you want to understand why they're relevant, or perhaps you want to have a good explanation for your boss who asks why you wasted time on this session. So I'm going to start by explaining why execution plans are important. Then I'm going to go over where to find them. And of course, the most important part of this session, how do you read the execution plans and how do you read the properties of execution plans? We will end with one or two examples depending on how I am for time. Oh, talking about time, I should have said this before. If you have any questions, just type them either in the discussion tab or the questions tab. I'm just going to give my moderator an extra task. Eugene is my moderator today. He will keep an eye on both the questions tab and the discussion tab. And if there's any questions that are relevant to the content of the session, he will unmute himself and just interrupt me. So ask your questions right away. No need to hold them until the end. I'm happy to answer all questions I can. So let's get started. Why should we even care about execution plans? Well, to understand that, you have to understand a bit about the difference between traditional third generation languages and SQL, fourth generation language. So traditionally, third generation languages like C Sharp or Basic or PL1 or COBOL, they're all third generation languages or so-called procedural languages. And those languages provide a step-by-step description of what the computer should do, step by step. So a third generation programming language is like me describing my morning ritual as the alarm wakes me, I hit the snooze button, the alarm wakes me again a few minutes later, I switch off the alarm, get out of bed, go to the bathroom, take a shower, brush my teeth, dry off, get dressed, go downstairs, have breakfast, kiss my wife goodbye, get in the car, drive to the office. This was a pre COVID example, and start working. Step by step description of the order in which I want to go through my steps. You might have a different morning routine. Maybe you brush your teeth before showering, or maybe you dry off before showering. I wouldn't recommend it, but who am I to judge? Anyway, that's how a third generation language instructs a computer step by step. Do this first, then that, etc., etc. And because computers are very good at dealing with large collections, that means we have to step through that collection one element by another, which means we often use loops in computer programs. And a loop will just load the first element into memory, do whatever it needs to do with that element, then read the next, and just repeat that until done. And often there are multiple choices on how this looping can be implemented exactly. For very simple problems, there's only one solution. But for more complex problems, there's often multiple possible solutions, and those are called algorithms. And it's the developer who chooses the algorithm because the developer writes out the instructions step by step to the computer. So if you have code and it runs slow, who can you blame? The developer, because they didn't choose the best algorithm for the choice. The developer wrote the code, so let the developer fix the code. Makes sense, right? But that's all third generation language. SQL, structured query language, is a fourth generation language where the coding is not procedural but set based. What SQL does is give a very concise description of the result we want. Give us a list of all people sorted by last name who made more than $50,000 last year. And then we don't care how this list is made, we just want the list. So we describe the requested final result set, but not the steps to get there. So let's step back. I'll go to the details later. If I return to my morning routine example, the way I described it, that was third generation language. But my boss might send me a message on my phone reading, "Hey Hugo, we have an important customer tomorrow, so make sure you're in the office by 9 and dress for the occasion." And that's it. She doesn't give a, let's rephrase that. I have an American audience. She doesn't care whether I shower before or after brushing my teeth. She doesn't care whether I have a long breakfast and then go to the car office, or whether I sleep in and have a hasty sandwich while driving to the office. She only cares about two things. I should be there by 9, and I should look my part. So she is talking to me in SQL, in fourth generation language. She describes the result and she leaves it to me to determine how to achieve that result. So SQL is set-based, and that means that so-called set logic is applied to input collections, which are also sets. Logically, this is defined as all at once. If you talk about the logic of SQL, it's always the theoretical notion that everything happens instantly, at once. In reality, that is not true. We all have been sitting waiting for a query to finish. Computers still process only one element at a time per core if they have multiple cores. So SQL Server has to do a translation of this set-based logic in the language to the one step at a time processing of the underlying physical hardware. And that's what the query optimizer does. The query optimizer is an incredibly smart piece of software that tries to come up with the best way to achieve your results. But the bottom line here is tries to. It's not perfect. It's incredibly smart, but it's not perfect. But it's the query optimizer that chooses the algorithm, not me. I cannot choose it. So when the code runs slow, who gets the blame? Yeah, me. My boss will blame me. And I can say, hey, it's not my fault. It's the query optimizer. My boss will say, I don't care. I pay you to fix it. And she's right. I need to fix this, even though I didn't choose the algorithm. And that's where it gets hard because the third generation language a developer can simply open up their code, start changing the code, and implement a different algorithm. I do not even know what algorithm was chosen. So let's take a step back from SQL in general and move to SQL Server, where we deal with T-SQL, an implementation of SQL. Now in T-SQL, we have a mix of set-based queries and procedural code. We can do loops, we can do if, then, we can do all kinds of control flow. So if my query is slow or if my code is slow because there's lots of procedural code with loops and stuff like that, I can try to rewrite the procedural code as set-based code. That often works because SQL Server is really optimized towards set-based code. I've been told that other databases are not as extreme, but SQL Server is extremely optimized to deal best with set-based code at the expense of being a bit slower with step-by-step code. So in that case, I can solve the problem. But what if I have code and there's a single query that runs slow? There's a single query, maybe it's the only query in my procedure, maybe the rest of the procedure is fast enough, but there's this single query that takes 5 seconds and I really need it to finish in a half second. Apparently the optimizer didn't choose the best algorithm. So how do I know what algorithm? Well, that's what the execution plan is for. In the execution plan, I can see what algorithm was chosen, and that is why I care about execution plans. Of course, knowing the chosen algorithm is only the first step. The next step is to start thinking about what other algorithm should the optimizer have chosen, why did it choose badly, how can I change the query or my indexing to make the optimizer pick a better algorithm. Those are all beyond the scope for today. Today, we're just going to talk about execution plans help you understand what algorithm was chosen, why this query is slow, and that's all I have time for now. So now that we know why execution plans are important, I need to find them, obviously, unless, Eugene, there are questions at this time.
Nope, nothing. Keep on rolling.
I'll keep on rolling. So we are now all convinced that execution plans are relevant and we want to find them. Where do we find them? Well, that depends on server, and your monitoring tells you that the entire server is slow, memory is overburdened, CPUs are spiking at 100, and you get complaints from across the company from people who don't have extreme slowness, but the whole system feels sluggish. So basically, your server is overburdened, and there may be several execution plans being slow, and you need to find them. That's a very relevant issue, but it's not in scope for today. So I'm going to mention that you can use plan cache, query store, extended events, trace. I shouldn't mention trace, but I do it anyway. Monitoring tools, various DMVs, but I don't have time for that. In the end of the session, there will be a slide with links and resources for further reading, and especially Grant Fritch's book on execution plans has a lot of information about all these tools, to help you find problem plans on a production server. But that's not what we're going to talk about today. Today, we're going to talk about the scenario where we have a scenario. So maybe you are a developer, maybe you are a DBA who also does performance tuning. You already know what query is slow. Maybe you just wrote it and you're testing it for performance. Maybe your DBA used all the tools on the previous slide and now comes knocking on your door and says, this query is really slow, fix it. Either way, we have the query and now we want to find the execution plan. So let's jump into the demo and we'll see if we can find an execution plan for this query. Now, this example is a bit weird. When my DBA comes to me and says, this query is slow, and I see a call to a function literally called delay, I think I can answer his question pretty fast. We're not in a realistic production environment here. We are in a demo environment, and I created this demo deliberately to have a very simple illustration. So yes, this is not a query I really would need to put a lot of effort into tune. It's just a simple explanation / example. So I'm in the correct database. I'm highlighting the query I'm interested in. And now on the top of the screen, there is this button. And if you hover over it, and I will do that once I am out of the zoom it, then you will see that it's marked as display estimated execution plan. I do not like the term estimated execution plan. It's a confusing term. It should be changed. But for now, this is the term that Microsoft uses. If I click this button, what SQL Server does is it shows me the execution plan. So at the top of the screen, a new window opens that shows the execution plan. If you've never seen one of these before, congratulations, you're in the correct session. I'm going to explain how to read it later. For now, this is just a way to get the execution plan. Now, this is just one way, and I call this way the execution plan only, but there's other ways as well. So there's also a button here, and I'll zoom in again. That's this button, and it's called Include Actual Execution Plan, another term I hate and that I personally refuse to use because it's just the execution plan plus runtime statistics. So if I click this button, nothing happens. What? Nothing happens? Well, something happened. It just changed color. It is now indented because this button is simply an on-off switch. And when it's turned on, and I execute the query, and this will take a time because, like I said, this query is slow. But once the query finishes, and that should take, I think, about 10 seconds the last time I tried this, once it finishes, it's more than 10 seconds today, obviously, because I'm doing live presentation. Now you will see a new tab open here at the bottom marked Execution Plan. If I click that tab, we see basically the same picture we saw before, the same execution plan, but there is some additional information here that we didn't see when we asked the execution plan only. So there's some additional information, but it's the same execution plan. Now there's a third button as well, and let's first disable the execution plan plus runtime statistics, and the third option is called live query statistics. So that also is a toggle button. So if I switch this query or this button on and I execute the query again, you will see that it immediately shows the execution plan, and then it executes the query. And while it is executing, you see those counters being updated as the query is running. So basically we had the execution plan only, also called estimated execution plan, which doesn't execute the query, hence is very fast, but also doesn't give any runtime statistics because it doesn't run the query. We had execution plan plus runtime statistics, which only shows you the execution plan after the query has done running. And if there's an error, unfortunately, you do not even get the execution plan. One of my biggest gripes with that. But once it's finished and shows you the execution plan, it has a huge amount of runtime statistics. And then on newer versions of SQL Server, there's the live execution plan that shows you some of the runtime statistics. It's not visible on the screen, but this version actually shows less runtime statistics than the version I showed before, the execution plan plus runtime statistics. But it does show you while the query is running. So if you have a query that runs for 2 hours and you start this option, maybe after 5 minutes, you already see what the problem is. And if you had asked the execution plan plus runtime statistics, you would have had to wait for 2 hours before you could even start investigating. So this option can definitely help you in some cases. Any questions at this time, Eugene?
Nope, no questions so far. Looking
Okay, then
good.
I'm going to do a quick recap. So we have the execution plan. Sometimes I call this execution plan only to make it very clear that it's execution plan without additional data. It's also called the estimated execution plan. The reason I dislike that name is because the names estimated execution plan and actual execution plan, first time you hear that, you are almost bound to think that SQL Server has two different ways to come up with an execution plan. One that's sort of a guess that it quickly does, or I'm probably going to do it this way. And then another algorithm to come up with the execution plan that it will really execute, which might be different. And I've seen so many people actually saying, yeah, you shouldn't look at the estimated execution plan because the actual execution plan can be different. That's compiled in a different way, and it's simply untrue. That's why I hate those terms, because they cause too much confusion. So the execution plan only is just the execution plan. What happens is SQL Server tells the optimizer, here's a query, tell me how to execute it. The query optimizer comes back with a plan, says, hey, you can execute it. And at that point, SQL Server engine says, haha, fooled you. I am not going to execute it, but I did trick you into giving me the plan. So the optimizer really thinks the query will be executed. It doesn't know that it's for only getting the plan. So the plan shows how it will be executed. And the only exception is if there's at runtime something that triggers a recompile. Recompiles are beyond the scope of this session, but recompiles are the only case where you can get the impression that when you ask an estimated execution plan and then later look at the actual execution plan, you see different plans. That's not because the plans are different, but it's because during execution, the plan recompiled and different information resulted in a different plan. Second I showed was the execution plan plus runtime statistics, sometimes shortened to execution plan plus, and unfortunately called actual execution plan. Here the start is the same. The SQL engine tells the optimizer, I need a plan for this query. The optimizer comes up back with a plan and says, go ahead, execute it. And then the engine executes it. And while executing it, keeps track of several runtime statistics. Those will then be added to the plan when execution is completed, and that is returned to Management Studio or whatever client you are using. So the plan shown is the same plan as the execution plan, only with all those additional runtime statistics added. And if your query doesn't run too long, if you can afford to have an execution plan plus runtime statistics, then I would always go for it. The reasons you might not want to do that is if your query runs for 2 hours and you don't want to wait for it, or if you are tuning an update or delete statement and you cannot afford to update or delete your data. If you have to tune it on production, for instance, it's not recommended at all to tune on production, but sometimes you have no options other than to just bite the bullet and do exactly that. Well, for updates, deletes, and inserts, that's incredibly dangerous because you can't just try them on a production system. The last option we showed, depending on the version of SQL Server might or might not be available, is the execution plan with live statistics, or for short, live execution plan. Again, the optimizer is just told, we are going to execute this query, give me a plan. The optimizer comes up with a plan and says, here's your plan, go ahead, execute it. And in this case, the plan is shown and then it does actually execute. And Management Studio keeps polling some internal structures to update some of the runtime statistics while it's executing. So here I'm going to quickly remove my camera from the image. Here is a short overview of all the differences and considerations of these three types of execution plans. I'm not going to go through all the details. You can download the slide later. The intention is not to speak through all the details of this. The intention is to let you know that there is an overview and to urge you to download the slide deck later and look at the details. So I'm going to move to the next slide already, and we're going to talk about how to read execution plans. And again, Eugene, at this time, a question would be very convenient.
Yeah. So we've got two questions, although one of them you already kind of touched upon. So the most popular one is from Derek: is does enabling any of the execution plan options hurt performance?
That's a great question. So if you just request the execution plan only, you are just kicking off a compilation. That takes some CPU cycles, but not much. Compilations can be a problem if queries are constantly being recompiled in production. But no matter how fast you hit that button on Management Studio, you're not going to overburden a production server with your compiles. So execution plan only should not be a problem. Execution plan plus runtime statistics and live execution plans do come at some overhead, but it's very small. So it is there, but it's not much. The only overhead I personally always care about is if I have execution plans that are relatively fast and I need to tune them. Then I look at the execution plan to find the problem. And of course, because they're fast, I will always use the execution plan plus runtime statistics to have most information I can get. But when I want to check their actual comparison, I turn off the execution plan to get rid of that overhead, because in queries that I need to tune down from 50 milliseconds to 10 milliseconds, those 1 or 2 milliseconds of overhead actually start to matter. But if I'm tuning a query for a report that runs for 5 minutes, that overhead of the execution plan doesn't is completely negligible. I hope I pronounced it correctly.
Yeah, the other question, and you touched upon this a little bit, but have you ever seen a case where the estimated execution plan ends up being different from the actual execution plan?
So the cases I have seen is when you have some code in your window, you request an estimated execution plan, and then you execute the query with the so-called actual execution plan enabled, and you get something different. There are repros for that, and if you look at them, you will always find that there is a place in the code that triggers a recompile. And that's beyond the scope of this session to talk about why that happens. But if you look at the underlying mechanics, what then happens is if you really execute it, you still get the same execution plan, but you never see it because the query is recompiled later before it executes. SQL Server still starts with the same execution plan. Now, in those cases, you would, of course, need to look at the final execution plan that actually executes. So that would definitely be a case where looking at the execution plan only and not realizing there's a recompile might waste your time because you're tuning the wrong thing. And in those cases, you would definitely need to look at the final execution plan by looking at the execution plan with the runtime statistics. So I'm not saying that they're never different. The reason I'm so pounding on that is because I want to get rid of this false idea that is looping around on the internet. And I've actually read a blog post once that almost literally said that the process to come up with an estimated execution plan is a lightweight process that just does a first guess at how it's going to execute it. Well, we are not humans working for a project. If I do a project to remodel my garden, I might come up with a rough estimated plan first, then talk to a gardener and then refine it into the final plan. But that's not how SQL Server works. SQL Server has one optimizer and it has only one way of working. That's create an execution plan.
Yeah,
So
I
yes,
think
yes.
I was going to say, I think it's also worth mentioning that, even if the same shape and structure are identical, depending on statistics or something, you can have wildly different estimated rows or that sort of thing compared to the actual result. I mean, I know I've seen something where it thought 90%, well, work is a interesting term, but it thought a lot of work was going to happen in a sort, and then it ended up that the actual query had 0 rows, so there was nothing to sort.
I think I have a demo about that coming up. So
All right.
let me continue.
Yep.
Great point indeed. So how do you read execution plans? Here is an example of an execution plan. And normally I would ask the audience, but now I have only Eugene because I know the audience is on a small delay. So Eugene, how do you read this? Left to right, right to left?
I like to read from right to left. I like to imagine I'm starting where the data is and I'm kind of driving my way to the destination.
You agree with 98% of my average audience?
Nice.
And like 98% of my average audience, I disagree with you.
Oh, no.
I want to say you're wrong. Well, I actually, I'm going to say you're wrong because right to left is. Oh, I thought I had this slide coming. I might be confusing multiple things. I may get back to this, and if I don't, remind me of it to come back during one of the question sections. because I want to talk about it. I think I have a slide about this, but I forgot the order in which I have my slides.
Okay.
So on this picture, we have an execution plan with some elements. It looks like just a picture, but what do we see on the screen? Well, to start with, there's two different elements. There's the nice, pretty pictures, the icons. Those represent something called operators. And an operator is basically a small program that can do one task very well. And that's it. And then we have the arrows, and the arrows represent the flow of data. And if you look at the underlying XML of the execution plan, because every time we look on the screen at an execution plan, we actually see Management Studio rendering the data that is captured in XML. The execution plan that Management Studio receives is just a block of XML. And this is a representation of that is easier on my eyes than reading that huge block of XML. Those arrows are not in the XML. They are just a representation of how elements are ordered relative to each other in the XML. They're still relevant, but it's important to know that actually the execution plan is just the operators, nothing else, ordered in a specific fashion. So let's talk in a bit more detail about those operators. Like I said, small programs that do something. So what do they do? Well, each operator has exactly three functions. There's three entry points at which where they can be called by the underlying software that runs SQL Server. So SQL Server's execution engine just calls those operators using one of the entry points, initialize, which is basically tells the operator, I need you to prepare to start working. And you would think that when you run a query, each operator is initialized once. That's often the case, but not always. There are scenarios where operators are re-initialized, and then they have to start from the top. And when an operator is re-initialized, that may mean it's going to do the exact same thing and return the exact same data. It also may mean it is going to do the exact same thing, but with a different value passed in, so it's not going to return the exact same data. Imagine an operator returning all rows where state equals California. That would return something, and then that same operator could be re-initialized. We need you to again return all rows with a given state, but now it's not California, now it's Texas. Well, obviously it's going to do the same functions, but the result will be different. But it's important to realize operators may be initialized multiple times. The most important call is getNext. Operators are constantly being called by getNext, and getNext is simply, hey operator, give me a row. Then that operator does whatever it is supposed to do to get that row ready and return it to its calling operator. And this does often involve calling getNext on yet other operators, because if I need to return a row, I need to get that row from somewhere. And most operators do not have access to data on your disk, so they need to get it from other operators. And then there's the close call that's just used at the end to clear up memory use. It's not relevant at all. I'm glad Microsoft made it because it saves a lot of memory leaks, but I don't ever need to care about it. The term operator is overloaded and maybe confusing, but it is what it is. So I'm going to explain the two meanings of the same word operator. So there is the meaning says an operator is as a generic type of operator. So if you go to my website, execution plan reference, you will find on the page about filter, the text, I think I copy pasted this. The filter operator applies a predicate to its input rows and returns only rows for which the predicate evaluates to true. If this is a bit hard to understand for you, that's okay. Like I said, execution plan reference is not targeted to beginners. This is the very precise explanation. The more beginner-friendly explanation would be the filter operator reads a row, checks whether it matches a condition, and only returns the row if that expression matches. So basically a where clause. That's a generic description of the filter operator as a family of operators. But if you look at the specific execution plan, a coworker might tap me on the shoulder and say, hey, Hugo, can you look at this execution plan I have on my screen? Because I see a filter operator here, and I see a filter operator here, and I see one here. Now, these two I get, but this filter operator here, why is it there? What does it do? Now, he's talking about three filter operators, not as the family of operators, but as members of that family. And in both cases, you use the term operator. For all filter operators as a family to describe their common characteristics, and as one specific occurrence within that family. And yes, that's confusing, but that's the terminology. And most of the time, the context makes it clear what people mean. So we talked about operators. Then there's the data flows, the arrows, that are not even in the XML, but they are shown on your screen to represent which operators are called by which other operators. Remember, an operator is called by its getNext method. And then in order to get data, it might call other operators. Which other operators? Well, that's what the arrows represent. And then it's important to know that each operator can be called by, and hence return rows to, exactly one other operator. That other operator is then called the parent operator. And obviously, if that other operator is my parent, then I'm that parent's child. So that's the terms parent and child are used to determine which operator the parent calls which other operator the child. Each operator has exactly one parent, but each parent can have 0, 1, or more child operators. So it's not a one-on-one relationship. And if you look at this, where each child has one parent, each parent can have 0, 1, or more children, you get what mathematicians call a tree structure. It's part of graph theory. You don't need to understand graph theory to work with execution plans. But if you know that this comes from graph theory, then you start to understand some of the terminology sometimes used with execution plans, such as nodes as a different word for operators within a plan, the second meaning of the word operator. And also terms like subtree or descendant operators are all related to graph theory. Yeah, I knew I was going to talk about this. So common misunderstandings. Let's first talk about the cost percentage. So we'll get to the direction later, I promise. I now know for sure that I have something about the direction, but I'll start with the cost percentages. And I think that is what you were alluding to previously, Eugene. By the way, are there questions at this time before I jump in
Uh,
the next demo?
yeah, we have one question, and I asked for clarification. I think I understand. The person's asking with estimated execution plans, does it cause any problems if you have temporary objects like tables that don't exist at the beginning of the script? So objects that are being created midway.
Yeah, definitely. If you have a batch with multiple statements, and a second statement creates a temporary table and the third statement uses that, you want to have execution plan only for that entire batch, you will get an error message. Because if you actually execute it, what it will do is it will try to come up with an execution plan for every statement. And at that third statement, it will say, okay, I need to defer this one. I'll get back to this one later because I don't have the object yet. But I know I'm in a batch. Maybe someone solves my problem before I actually need to execute. So it basically skips that. And if you then go ahead and run it, the statement will automatically recompile just before it needs to execute. And then it will check, is the temporary table now there? Hopefully it is, if you didn't make a typo in your table names. If you ask execution plan only and you use an object that doesn't exist, well, it can wait until it is made, but your code won't run, so you'll just get an error.
Gotcha. Great. That's it.
Good. So on my screen, you see a sample query. And again, do not take this as a realistic example. This is just me brute forcing something that I wanted to show. But let's assume that this is a complex query. The highlighted code is a really complex query. It's running too slow. And my boss told me, Hugo, this needs to be faster. And I looked at it and I said, okay, I think I have a better way. But now I need to verify my work. So let's first make sure I'm in the right database. And then I'm going to highlight this code. and ask for the execution plan only. Because why would I execute? I will just look at the execution plans, because there is this little handy thing in the execution plans, and I'll zoom in and highlight it, where it says query cost relative to the batch. So the entire batch is measured at 100%. This first query, the original one, was 99%. And then I did some tuning, and if I run them together, then together they're 100%, and my version is 1%. 99% faster. I'm a query tuning god, right? I'm awesome. I've earned my pay for the day. I can just play games and watch cat videos the rest of the day, and my boss will be extremely happy. And then someone will say, and I don't like the terminology, but someone will say, yeah, but it's an estimated execution plan, and they might not match the real execution plan. And I could then go into a full-blown explanation and go on my soapbox of why they shouldn't use the terminology. Or I can just say, well, I'll humor you. I'll do the execution plan plus runtime statistics. I'll execute this. In this case, it's a fast query anyway. And see, here's the actual execution plan. And look at the query cost. I really am the absolute god of query tuning. Nobody tunes as good as I do, right? I hope that everyone in the audience is now completely objecting to my characterization of myself as a query tuning god, not just for religious reasons, but also for misleading you. I think I overacted sufficiently that you realize that. So I'm going to disable the execution plan, and I'm going to enable some other measurements. So I'm going to ask SQL Server to track how much time each query took and how much I/O it takes. Going to execute it again. Now I don't get an execution plan, but I got some extra data in the results tab. And if I look at the first query, the one I needed to tune, that took 689 logical reads, and it took 22 milliseconds. That was too long. I needed it to go faster. Well, this query tuning god made it faster. We know that. So let's look at the data. And now it took, wait, what? 74? And it did almost 100,000 logical reads. That's not 99 times faster. Something went wrong here. Something went horribly wrong. Let's return to the execution plan and try to understand what is happening. So yes, I do the execution plan plus runtime statistics. Now I'm going to hover over this select operator, and I show you there's a measurement here called estimated subtree cost 0.584. If I do the same thing for the other query, the estimated subtree cost here is 0.065. And if you do the math, you will see that this works out to 1% and 99% if you add them together. Here's the thing. Estimated. It's an estimated cost. I can't underline this enough. Estimated, not actual. There is no actual cost in the execution plan. So whether I use the execution plan only or the execution plan plus runtime statistics, the costs are always estimated. And what if my estimates are wrong? For instance, in this case, I estimated that there would be one row. In reality, there were 31,000. My estimates was wrong. So somewhere in SQL Server, a mistake was made while trying to predict how much work would be needed. And that mistake caused SQL Server to first choose this execution plan, which would be ideal for actually one row. And second, tell me that it would be very fast if a reality was indeed just one row. Now, if you know that this 99% number and this 1% number, that was not what I intended to do, are so misleading, do you still trust sometimes my screen doesn't want to do what I want. Do you still trust this 93% number? Well, this 93% number happens to be based, and I know this is from a different operator, but it happens to be based on the estimated subtree cost and the estimated CPU cost and the estimated IO cost of that operators. And again, all of them are estimates. So this 93% is also based on estimations, not on reality, even in an execution plan with runtime statistics. And no matter how often you execute the query, those numbers will be based on runtime statistics and not on reality. So yeah, those percentages look deceptively easy, but they may be just deceptive. Like I said, they're always based on the estimated cost. That's the only thing Management Studio has. There is no actual cost in the XML it receives, so it cannot compute a percentage based on actual cost. So if your estimated row count is wrong, those percentages will be wrong. And here's the thing, a very substantial amount of queries that I need to tune are slow because there is a misestimate somewhere. I'm not going to say it's the most common. The only reason I'm not going to say that is that I didn't keep statistics and I can't back it up. It's not because I think it's a wrong statement. Very often, a major cause of slow queries is a problem in guessing how many rows there will be flowing through each operator. And those cost percentages are based on those guesses. So my query is wrong because the guesses are wrong. And I'm going to optimize it by looking at percentages that are based on those wrong numbers. And somehow my efforts don't work. Yeah, big surprise. I shouldn't be looking at those numbers. But even if the estimates are correct, then you should still be careful about the cost percentages because those percentages are based on hardware assumptions that are slightly outdated. The underlying costing model was built in the 90s of the last century when 2 gigabytes of data of buffer pool was a lot. And when the fastest disks were spinning disks at 14,400 RPM. And when parallelism meant that you had 2 processors in your high-end server. That's the reality that those numbers are based on. So even the costing model isn't correct anymore. So if the estimates are correct, then the percentages will be more relevant, but you should always be careful and not jump to conclusions based on those percentages. I'm not saying never look at them. I'm saying look at them, but know what they represent, and most important, know what they do not represent. And now we get where I wanted to go, the read direction. Here we have an execution plan. How do we read it? Left to right, right to left, something else? Eugene says right to left. 98% of my average audience agrees. So before I give my answer, let's return to what an operator does. An operator responds to a get next call. Now the select here is not a real operator. The select is a representation of the client program asking for a row. So the client program, Management Studio, or your application says, hey, give me a row. And Filter says, sure, I'd love to give you a row, but I need some rows first. Hey, table scan, give me a row. Table scan says, yeah, of course, here's your row, go ahead. Now Filter has one task, and that's look at the row and determine whether the row is good enough or not. And it says, no, this row sucks, I don't want it. Give me another row. The table scan is like, sure, whatever, here's your row. And Filter looks at the row and says, oh, this is a great row, I like it. Select, here's your row. Now, I used 2 colors, and I know that not all colors are equally visible for everyone. So I have red running left to right labeled get next, and blue arrows labeled right to left with no label below that. The red arrows represent the flow of control. They represent in what orders operators start working because they are asked to do work. Blue arrows represent the flow of data. They represent how data flows through the execution plan. Both orders are important and extremely critical if you really want to understand execution plans. And yes, it's true that for complex execution plans, the best way to get to a quick understanding is mostly to follow the data. Mostly. But you should be aware that order of control is left to right, because there are operators that under some conditions will stop calling their descendant. So imagine that you have a huge execution plan and you see a complete Christmas tree of operators all calling each other, and you start looking there and you spend 2 hours deciphering everything going on in that execution plan, completely going right to left and working your way up until you find an operator and you look at the properties of that operator and it says, oh, for this specific execution, I never called that tree. It didn't run at all. well, then you feel silly because you just wasted 2 hours looking at possible optimization stuff in things that didn't run at all. And that's the big error you make if you only read right to left. Now, only reading left to right doesn't work either, because that's simply a complexity issue. It's for our human brain, it's easier to understand by following the data. And in more complex execution plans, I just start by scanning the whole plan, looking at specific areas, looking for red flags. And yeah, what are red flags? That's experience. There is no simple answer to say you should always look here. The more execution plans you see, the more execution plans you study, the better you get at realizing this section is suspect, or this section is doing something weird, or simply, I don't understand this section. And I myself have learned a lot by, when I have some time, even just looking at execution plans of queries that perform well. Normally, we don't look at execution plans for queries that are fast enough, but I'm a geek and I want to get into the details. So I routinely, very often, just look at execution plans to see if I understand how the execution plan implements the logic of my query. And doing that often made me better at recognizing, hey, something weird is going on in this specific section of the execution plan. Do we have questions at this time?
Yeah, we've got two questions. So
Cool.
one of them, I'm a little bit fuzzy on the original context, but when you were doing the demo, the person's asking, so I'm clear, these estimated costs displayed after the query has been executed.
Mm-hmm.
Okay, just wanted to, so that is a yes. The other question is how do,
Sorry, I didn't.
you heard you
I
understood the
understand.
question. Yeah, so we'll start over. The question is, those estimated costs that you showed, were they displayed after the query had been executed?
In the last demo, they were displayed after the query was executed, because I executed the query and then looked at the execution plan plus runtime statistics. But I
Okay,
also had one occurrence where I looked at the execution plan only without executing the query, and then looked at the estimated costs. Estimated costs are in every plan because they are put in the plan while the plan is compiled. So you
got it.
will find them in the execution plan only, aka estimated execution plan, and you will find them in all other execution plans, because all the other execution plans do is add extra data to the execution plan. They don't remove anything, they don't change anything.
Perfect. The other question is, how do remote data sets such as linked servers affect a local execution plan?
A great a question, and completely out of scope for this session. So I'm going to give a very brief and unsatisfying answer. If you have remote operators in your query, then you will find specific operators in the execution plan. I think they're called things like remote scan or remote insert if you modify data remotely, and a few others. They all have something the remote in their name. And then in the properties, we'll talk about properties later. In the properties, you will see that a part of a query is pushed somewhere else. So one of my customers has a lot of linked servers, and then sometimes I have queries that do remote scans or remote seeks or remote executions, and then I have to look at the properties to see what code is sent to that other server. And in my case, the other server is always another SQL server. And then I can take that code and start debugging that code on that other server, because I need to go to the other server to find the execution plan for the code that is remotely executed. And obviously, if remote code is pushed to, for instance, Excel, I don't even know exactly how it works. I know that you can use Open Query to get data from Excel. I assume you will also see remote operators for that. And Excel doesn't allow you to see the execution plan, but the options there are more limited.
All right, great.
Yeah.
That's all the questions we have right now.
Great. So let's go talk about properties. If this is your execution plan, then this is the part we've been looking at so far, the tip of the iceberg. Most of the information is not in that little tip. Most of the information is buried below the surface in the properties. And if you are serious about looking at execution plans, you should look at properties. And actually, I already did so in some of the demos. So let's just jump into a demo to understand one simple example where properties are very important. Let's first make sure we're on the right database. Now I have two queries here and they're quite different. If I select them both and just ask for the execution plans, you will see two identical execution plans. You see no difference if you just look at the pictures. Now, the execution plan is the only thing that the execution engine gets. The SQL Server execution engine only works based on the execution plan. So I would expect if the engine gets two identical execution plans, that two identical result sets will be returned. But you can already see that the first result set and the second result set have a different amount of columns. And if I click in the first result set and then highlight the number of rows, that's 20,000 rows. If I do the same in the second result set, it's only 15,000 rows. So different columns, different rows, and yet the same execution plan. And I forgot to enable execution plan plus runtime statistics, but it's there now. And they look exactly the same. So how does this happen? Well, like I said, you need to look below the water, under the tip of the iceberg. So if I hover my mouse over the clustered index scan, you will see this pop-up. And in this pop-up, you will see, for instance, a property called output list. And here you see the 5 column names I had in my query. So this is how the execution engine knows I should only return those 5 columns. You also see something called a predicate that says, hey, modified date should be at least 1st of January 2013. So this is how the execution engine knows not to return all rows, but only the rows that were modified somewhere in the last years. If I do the same here, you will see that there is no predicate. And that's why this specific execution plan returns all the rows. And you will see a much longer output list, in fact, so long that the end shows an ellipsis. That means that ellipsis is a signal to me saying, hey, I have limited space in this pop-up. I gave you as much as I could, but it's incomplete. Be aware that you don't see the complete data here. And if I do that, if I see that, I can right-click and click Properties. And when I do that, the only thing that happens is that this window here gets focused. I always leave this window open. You can close it, then it will reopen when you ask for properties. But if you just leave it open like I do, you don't need to go through the right click. I can just click somewhere. And if you look at the right part of the screen, when I click everywhere, you will see that every time I click somewhere, the data there changes because it shows the properties of whatever is currently highlighted. Now this index scan had this long output list that didn't fit completely. And I can just scroll through this property list. And you will already see that there's even more properties there. So for instance, this, sorry, I messed that up. This no expand hint is never in the yellow pop-up. That's simply a property that Microsoft considered not important enough to always be highlighted. Then you will see this plus before the output list, and I need to jump out of the zoom it before I can click it. So it will be behind my face now. I'm going to click that plus and then scroll down a bit and then zoom again. And now you will see that there's a long list here. And if I scroll more, or you know what, let me just break out this window to, well, this was not what I intended. Let me quickly try that again. If I break out this window to here and make sure that the correct data is there, I can just make it a bit wider. And then you can see in the output list a complete list of all the columns that are there. And here is no length restriction, so you will always see everything. Let me quickly, normally it is much nicer to me. Let me quickly return this to the normal position where I personally like it. This is just my personal favorite position. It's not a rule that you have to do it like this. I also want to highlight that you can hover over an arrow. If you hover over an arrow, arrows are not elements within the execution plans. They don't have properties, and yet they show properties. The properties you see here are actually a small subset of the properties of the clustered index scan. You will see the same data here as well. So it's a sort of summary related to the data produced. Let's return to the slides. Because I showed the various ways to access an execution plan, to access the properties in execution plan. Like I said, you can hover your mouse over the icon in the execution plan to see a subset of the properties. the subset is chosen by Microsoft, and I happen to not always agree with them on which properties should be there and which shouldn't. I often see a lot of space wasted in that pop-up for properties that are hardly ever relevant. And I often have to go to the other alternatives because properties that I need more often are not in this pop-up. You can hover over an arrow to get just a small subset of the properties of the operator to the right of that arrow, focusing on the amount of data produced by that operator. This is a very useful way if you are just interested in how many rows are flowing through this execution plan. I don't care about all the other details. I just want to get a first assessment of how much work is being done by each operator. Just look at the amount of rows. It gives you an idea. Then right click and select properties, or keep the properties window open and just click to change focus, which has all the information you will ever need. Everything is there. Now, I told you before the top left operator is not a real operator. It represents the client, but it still has properties, and those properties are not properties for the client. They are properties for the execution plan as a whole. And I'm going to show that as well. I'm going to just keep it briefly because I don't have time to explain everything. But
15 minutes.
If I hover over the select, you will see a very small, short selection of properties. And you're like, why is Hugo bothering me about this short section? Okay, some of them are interesting, but let's click it and let's break out the properties window again. Let's make sure I do it correct this time. So now you will see that there's actually quite a long list of properties, and I'm not going to explain all of them. I'm just going to highlight a few, like for instance, memory grant info gives a lot of information about memory used by the query. In this case, it's 0 because it's a very simple query. I can look at the query time stats. Remember when I used set statistics time on? Well, I could have just looked at this data in the execution plan, which is the same. I can look at wait stats to see what wait stats were used when this query ran. This is extremely valuable if you are given an execution plan with runtime statistics. Your coworker says this took 10 minutes, and normally it's just 8 minutes. What's going on? And you can look at the wait stats and perhaps see that maybe it was just waiting on a locked resource, and you see 2 minutes of waiting for a lock. Well, then you don't have to look at the rest of the execution plan anymore. There's a lot more in here. And there's also some properties that are not in this example, but that will show up in other execution plans. But I'm just going to tell you, always look at that list of properties as well. And then the other operators, there the properties are applied to that operator. So we saw examples of properties that influence how the operator behaves, like return only these columns or return only these rows. We've also seen examples of properties that are basically measurements of what happened in that operator, like the actual number of rows and other things. Now, what all those operators mean is absolutely out of scope for this session. Based on the name, a lot of them are fairly self-explanatory. And obviously, I have to plug my own resource again. This is exactly why I have a resource, so that you can look up what a property means on a specific operator or in general. So we still have a little less than 15 minutes less, and I'm going to ask Eugene for questions again, and then I'm going to dive into 1 or 2 examples depending on how fast we go.
Yeah, we've got just the one question right now. Maybe some more will come in. And this is probably another one that's a little bit on the edge of the scope of this session. Craig asks, how does dynamic SQL affect the execution plan? For example, code running through SP execute SQL, especially with variables added to the dynamic SQL.
Okay, the short answer that should be in scope for this session is that dynamic SQL is executed as a separate batch. So when it's executed, it's just a new batch hitting SQL Server. It will be compiled just as when you typed that code in a window and executed it, meaning it will be compiled to get an execution plan and then executed. There's more to this question about variables and parameterization and reuse of cached execution plan, and that's all completely out of scope for this session. So if Craig wants to discuss that further, he really should hit me up on Twitter or email, and we can talk further.
All right, great.
But I do not, I don't think it's fair to the attendees to go in more details than this.
Okay. Yeah, there's no other questions right now, so.
Okay, then let's move into my examples. And I have a demo where I'm going to try to put this into practice. And I know it's still all very shallow. I didn't go into much depth. That's comes with the term for a session like this. But I do want to see some of the things already in practice that you can already do. So I have a query here where I join the sales order, and I'll just make it a bit bigger, and it's just this query we're going to talk about. So I join sales order header and sales order detail, obviously on sales order ID is the same. So the obvious normal join. I'm only interested in product ID equals 710. And then what I want is to group by customer ID. And for each customer ID, I'm going to count the amount of orders with a simple count big and total sum of the quantities. But I don't want all the results. I want to order by descending total quantity, and then I want only the first 10 after that ordering. So I want the 10 customers that ordered the most quantity, and for them I want to know how much they ordered and in how many different orders that was. Now, when I run this query and I will enable execution plan plus runtime statistics, I will execute it and I will not even look at the results because I don't care about the results in this case. I care about the execution plan. And you will already see this is nowhere near as complex as you will see when you are doing your job or your normal queries, because it's still a simple query. But you will already see a lot going on just by looking at this execution plan. And in this case, I am going to go right to left to follow the data. So let's start at this index seek and look a bit at its properties. First, an index seek is an operator that uses an index to quickly find specific rows in a data collection. And there's a property called seek predicates that tells me what it finds. What it finds is rows with product ID equal to, and let's move my head a bit. You know what, let's just disable the camera. That's perhaps easier. No, I always forget that I can't disable my camera when I'm zoomed in. So it's equal to 710. I'll sit in front of it now. So this index seek gets data from, do as I tell you, not as I don't tell you, gets data from this index, filters on 710, what we saw in the query, and then it returns, and I'm going to try this one more time to make sure that everyone can see it. It returns, I give up. It returns, you can see in the output list, run this later, you can check the output list property to see it returns sales order detail, sales order ID and sales order detail ID. And that's weird. I just realized I can move myself. Maybe I should just do it like this. Yeah, that's better. Sorry. So it returns sales order ID and sales order detail ID. And that's weird. Why does it return sales order ID and sales order detail ID when in my query, yes, I do use sales order ID from the sales order detail table, but sales order detail ID is not even in the query. So why does the index seek return this column? That's weird. I don't understand this yet, but let's continue to follow the data. So these rows are then passed into a nested loops. And what a nested loops does is for each row, it will execute the other input. So basically these rows are passed. Oh, I intended to use this type of row, passed to nested loops. And nested loops will then call key lookup for those rows. And if I look at the nested loops in more detail, it will also tell me that something called sales order detail ID, hey, there we have sales order detail ID again, that value is then passed on to this key lookup operator. So this key lookup operator does something with sales order detail ID. And then we see that key lookup is basically the same as an index seek, just in a clustered index. So it's trying to find data in my table, not in an index. And it's finding the data based on sales order ID and sales order detail ID in the table being equal to sales order ID and sales order detail ID being passed in. So now I start to understand why here sales order ID and sales order detail ID were needed, because those values were then passed through the nested loops to here so that I can read the order quantity. And that's the idea of this entire set of operators working together. Now this nested loop then combines the data it gets from its two inputs, and it returns sales order ID and order quantity. We already see sales order detail ID is now dropped. We don't need it anymore. It was only needed for that key lookup. Now, if you follow the data further, we'll see that this data is then passed here. Sometimes I use the wrong buttons. My apologies for that. And then passed to here a clustered index seek. I happen to know that by head it's obscured now, of course. But if I hover this clustered index seek, you will see that here the sales order ID it receives is then used to find the customer ID from the sales order header. So this specific combination of this nested loops and this clustered index seek is basically doing this join, except that it doesn't read sales order header first and then joins the sales order detail. It started by reading sales order detail, filtered on product ID, added the customer ID because we need it as well, and then joins that to sales order header to find the rest of the data. And then it passes the customer ID and the order quantity, the only columns that are still needed for the rest of the column. Now this data gets sorted. I'm not really sure why yet, but I can check if I want to understand something. I always look at the properties. It's ordering by customer ID. So now the result, basically the result of the join is what we had. And now SQL Server is ordering it by customer ID. And I look at my query and I'm like, what? I have an order by total quantity. I have a group by customer ID, not an order by customer ID. So why does this happen? Well, let's see what happens with the data after sorting it. It's passed to a stream aggregate. A stream aggregate does group by customer ID. Now, SQL Server has two operators that can do aggregation, stream aggregate and hash match. Stream aggregate happens to require data to be sorted. So here, optimizer made a cost-based decision saying, okay, I can choose using a hash match and not sorting, or I can choose to use order by and then sort. Which of the two is the most expensive based on the estimated number of rows? Again, it does not know the real number of rows, but based on the estimated number of rows, it comes up with an estimate of which of the two will probably be more expensive. And that will then, in this case, result in the choice, I'm going to do a sort and a stream aggregate. So now the results after this aggregation, and I'm also going to point out the output list is the customer ID and two EXPRs. What is EXPR? Well, if you see EXPR, you will have to go to something called the defined values in the full property list. And I use the ellipsis to get the full information. Now I can see that one EXPR is count star and the other is the sum of the order quantity. And there's a lot of fluff in there. It's an acquired taste to read this, but you will see that here it computes basically these two aggregates. So not actually a surprise once you go into the details. The final step is a combination of a sort ordered by this EXPR 1003 descending. Hey, that's what we had in the query. And it's combined with a top n. And I need to go to the full properties list again, because this value for n is only available here. And it says I'm going to do the top 10. So this operator is a combination of sorting and only retaining the first 10 with an optimized sort algorithm for this specific context. Now I have a second demo and I do not have the time to talk you through it, but the only difference is here is that I increased the product number. The rest is just copy paste, but just using a different product number, SQL Server comes up with different estimates for the amount of rows, and that results in completely different choices. So I can't talk you through this execution plan. I only have 2 minutes left to wrap up. I do want you to appreciate that here, for instance, the hash match aggregation was chosen instead of sort plus stream aggregate, and many different things were chosen differently, just because the estimated number of rows was different. With that, I need to wrap it up. I am going to call out, please download for free the PDF version of SQL Server Execution Plans 3rd edition by Grant Ritchie. If you want a debt-free copy, you can order it from Amazon.com, but that's of course not free. If you need to look up something, go to the execution plan reference, sqlserverfast.com/EPR. if you're interested in more training from my person, the execution plan video training at videos.sqlserverfast.com. I'm not sure if that link is still correct. I changed something lately, but at sqlserverfast.com, you will find links in the menu. And if you have a Pluralsight subscription, there's a huge amount of information about execution plans there as well. Please do not forget to evaluate the session. I know we're almost out of time, so I could ask Eugene for questions, but I know I won't have time to answer them. So if there are any questions, I'll chat with Eugene after the session, and you can, I realize I don't have your contact, but you can mail me your questions if you have them, or ask on Twitter. Thanks for being here. And if nobody messes up and if everyone does as promised, then you should by now see a QR code for past prizes. Thanks for your time. Thanks for your attention. My name is Hugo Kornelis. Bye-bye.